All right, so the goal yesterday was to take this ability to find a function's exact rate of change at a point, its instantaneous rate of change, its tangent slope, and see if we could apply it to some applications. That was kind of the idea. The first two, I guess, were a little more conceptual. 17 was asking if this piecewise function was going to have a tangent slope at x equals 2. Um, well, the work shows that it will, because first of all, it shows that at 2 we're continuous. There's a continuity check of plugging 2 in, and well, actually, let's go do it, I guess. Here we go. So if we were going to ask ourselves, what f of 2 was as we came in from the left. So we'd be using this function coming in from the left, it would just be 1 over 2, okay? If we ask ourselves what f of 2 is as we come in from the right, so now we'd be coming in from this side, it would be 4 minus 2 over 4, which is 2 over 4, which is 1 half. So that's the continuity check, and absolutely it is continuous. Now, as far as whether or not the tangent slopes agree, that one requires a little work. And so I thought I'd do this one just because um, it has a rational function, and those rational functions are always a little bit more challenging. So the limit as h approaches 0 from the left. So the distance between the point and the secondary secant point is shrinking from the left side is basically what that means. And so we're going to do f of 2 plus h minus f of 2 all over h. And of course, this is the same work you would see in your course pack, but I'm going to try to um, give it a little bit of explanation behind it. So 1 over 2 plus h and 1 over 2 are those two values. And now we just have to do some algebra to try to simplify those down a little bit. So my preferred method would be to multiply by the least common denominator, which would be 2 times 2 plus h. You'd have to hit both the top and the bottom of the fraction with that though, right? And here's what's going to happen. We're going to get just a 2 on the top because the 2 plus h is canceled. 2 times 1 is 2. On the second term, the 2's will cancel, and I'll just get a 2 plus h. Okay. Don't forget those parentheses. 2h, 2 plus h. So that's where we now stand. Let us continue. Distribute the top, or subtract it, I guess, however you want to put it. But if you forget that negative has to go to the second term here, that's where you're going to be off by a factor of a sign, right? You're going to be off by negative. But those twos are gonna go away for you. So that's where we know we're about done. So the limit is h approaches 0 from the left of negative h over 2h, 2 plus h, cancel those h's. Limit as h approaches 0 from negative 1 over 2 times 2 plus h. And now we can plug that 0 in. When you plug the 0 in, you don't have to worry about which way it's approaching. I mean, it's just a 0. So negative 1 over 2 times 2 is negative 1/4. So keep that in mind. That's your left tangent limit of the secant as you approach the point from the left. What about the limit of those secant slopes as we approach from the right, right? Well, that would be the limit as h approaches 0 from the right of 4 minus 2 plus h over 4 minus 4 minus 2 over 4. So that's f of a plus h minus f of a, in this case 2, right? And, oh, shoot. I guess I would multiply through by 4, just because you can get rid of those fractions pretty easily. And so now we have the limit of 4, because remember these 4's are going to cancel with this 4. 4 minus 2 minus h, okay, don't forget that the negative has to be distributed, minus, let's just call it minus 2, because 4 minus 2 is 2, that simplifies that, and all over h. Well, the 4 and the negative 4 here and here, right, negative 2, go away, and so I do have a 4h on the bottom, and so I just get the limit as h goes to 0 of negative h over 4h, and those h's cancel, so really I just have the limit as h goes to 0 of negative 1/4, which we know is negative 1/4. So that's kind of how that works. But notice that it was the same limit, and this just kind of shows you. Here's the function 1 over x, so that's your function that we would be taking, I guess, this part of it right here, less than 2, right? And then here's the function 4 minus x over 4, which, by the way, if you split the fraction 4 over 4 minus x over 4, it's just like 1 minus 1/4 x. It's just a linear function with an intercept of 1 and a slope of negative 1/4. But we would take this part of the function from the right side of 2. And so that's what we're kind of doing, is we're taking this piece up here and this piece down here. I mean, I guess we could take a picture of this, and we'll just go right out to 2. Slight click, don't let it scare you. And although you might not even hear that on this audio. And then we shrink it back to the same size, and look at that. So here's the thing that's so awesome about what's happening here. Not only did we have the continuity, so the functions have the same y value at that breakpoint of 2, right? But these tangent slopes, as they come down from this vertical asymptote, so they're really, really steep as they come down, and then they finally start to flatten out, right? And we know that eventually they get incredibly flat around the bottom of this, because there's a horizontal asymptote at 0. So these things are getting, if you go way out here, the horizontal asymptotes are pretty much horizontal. They just the tiny little bit of slope to them, because you never actually get to 0. But these tangent slopes are definitely flattening out as you come around down here, right? But at this point right here, we have a slope of exactly negative 1/4, and then the line, the line actually always has a slope of negative 1/4. That linear function, was never going to have a different slope, and so you have differentiability is what you're going to call in calculus. For us, we just call it a tangent slope that agreement of tangent slopes at that value, and that's how you know that the tangent exists, even though it's 2 entirely different functions. Here is a piecewise function I did, and so the graphs are the same color, so you can't even tell that there's a difference, but you can see the you can see what I graphed. I graphed it as a piecewise function. I don't know if you remember, but back in probably February before your second exam, I showed you how to do that. And the only reason you really know that is because we know that a rational function 1 over x, right? This 1 over x right here doesn't go past 0. It comes down and it keeps going like this. Okay, and approaching the x-axis, horizontal axis. So when this thing breaks down like this, we're like, oh wait, that's not natural. That's not, it's supposed to kind of look more like this, but it doesn't. So we know that this is a different function, and that's where the negative 1/4 line takes over. But right here, look how smooth that is. That's how you can visually tell that you have differentiability, that your tangent slopes agree, is because there's a smoothness to the curve. You can't even tell that this is, if I didn't tell you what function this was, you wouldn't really probably even know what was going on there. Okay, so there's 17, and then 18. 18 would have been really hard because you don't know how to find derivatives of sine yet. Like if you did sine of 3 pi over 4 plus h minus sine of 3 pi over 4. I mean, sine of 3 pi over 4 is not that bad. That's just negative root 2, or I guess it's positive root 2 over 2. But how would you deal with the h? You can't pull the h out. You'd be stuck. In calculus, you're going to learn some ways of dealing with these trig functions. But right now, you don't. But here's the thing. Luckily, at 3 pi over 4, you didn't have to worry about it because look, these functions are not continuous at that point, right? These functions don't meet at that point. So you didn't have to end up worrying about that aspect of it. That's the first thing that you have to check, is that there's continuity with your graph. And so here you just say, is there a tangent slope that exists, a tangent line that exists at 3 pi over 4? The answer would be no, because the function is not continuous at x equals 3 pi over 4. Sine is root 2 over 2, but cosine is negative root 2 over 2. You have different y values. Now, one thing that's kind of cool though, and here's the piecewise graph of this situation where you have sine in control to the left and cosine to the right. Look at the tangent slopes. The tangent slopes actually do have the same slope. They both have look at how I compare those. They're exactly the same. But it doesn't matter if the slope is the same if you're not at the same point. I mean, think about it. Up here, I'd have a tangent line that would have a y-intercept, way up here, and this guy would have the same slope, but it would have an intercept way down here. So I mean, they would be parallel lines, but they wouldn't be the same line, and so the tangent line doesn't exist because you don't have continuity. So make sure you always check continuity first before you waste your time doing all the work. But there you go. All right, so then we jump up to 23. 23 was very similar to an example that we did yesterday that's built into your course pack on page 22. All the work for it is right here, so you can see it. And it's also very similar to problems 27 and 28. Maybe I'll do 27 or 28 for you in this video, but I'm not going to do all three because they are very similar. This is the exact work you have in your course pack, so you can see how it works. Remember, the negative 19.6 doesn't mean you got it wrong. It means that the velocity is negative. It's falling at a speed of 19.6. Once I say falling, I don't have to put the negative anymore because I've indicated direction. Okay. Maybe we should do 24 because this is a rocket that's just going straight up instead of something that's going straight down. It's really actually probably simpler than 23 because you don't have to be subtracting anything, just starting at ground level and going straight up. So I guess maybe that one's not worth it. Maybe we could just talk through the work here. They want to know at 10 seconds, so I plug a 10 in for A. And then I just have to remember, I guess the main thing here is I have to remember order of operations. I have to remember I have to square the 10 plus h first before I multiply by the 3. I think a lot of people want to multiply by the 3 and then do it, but order of operations says exponents come before multiplication. And so you have to square this first, get your binomial, then you can distribute, right? Bam, 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 the 3 across your trinomial. Every single time you do one of these problems, anything that doesn't have an h should cancel out, and here you see the 300s do cancel out, and then you can factor your h and you're done. So actually this one was, I guess we don't need to do this one. It's actually simpler than the other ones. And notice that this time the velocity we got was positive. Now you're just going to turn all your answers into positives because they just ask you for the speed on these problems, and speed is the absolute value of velocity. But notice you know, what I would want to say if it was velocities, the rocket's velocity is 60 feet per second up, you know, into the sky. I did 25 for you yesterday as an example. So I'll do 26 for you. How about I'll do 26 and then maybe 27 or 28. They look about, I mean, 28 has slightly bigger numbers, but doesn't really matter. And then then we did 29 together. So we could do 30. This is just a reminder of completing the square to put this into what we call vertex form of a parabola. If they want to know where the tangent slope is equal to 0, that's always going to occur um, when the vertex of a parabola is at the vertex of a parabola, I guess. So if I complete the square, half of 2 is 2 squared is 4, and then add 4, you know, that if I add 4 to one side of an equation, usually we add 4 to the other side, but in this case I'm only working on one side, so I'd have to subtract 4 later on. So plus 4 minus 4 balances the equation, but then I subtract the 4, that's where the minus 5 comes from. But negative 2, negative 5 is the vertex, and that would have to be where that tangent slope was, and that's kind of the problem we did yesterday. So I'll do 30, and let's do those 3, and then anybody else who has other questions, you'll just have to swing by the help session, okay? So 26, okay, the volume of a sphere. So as a sphere increases in radius, it's definitely going to increase in volume. It's going to increase in surface area. It's going to increase in volume, all of the above, right? So I don't know if they gave me a sphere in here. Well, kind of. I don't know if that's a very good one, but it doesn't necessarily look too three-dimensional. But as the radius increases, the volume increases, and it's increasing much faster than the radius because the radius is one-dimensional and the volume is three-dimensional. Okay, so here's what we know. We know the volume of a sphere is 4/3 pi r to the third power, pi r cubed. Okay, so let's call this the volume function v of r. Okay, so v of 2 plus r, so that's where the radius is 2, is going to be 4/3 pi 2 plus h. It's not 2 plus r, it's 2 plus h, sorry. 2 plus h squared, or cubed. Okay, so this is where it's going to kind of stink a little bit because you got to cube a trinomial. But I got to be honest with you, you may have to do this, you know, on a quiz. I don't think we'll go anything past cubing, but squaring binomials and cubing binomials is something you're just going to have to know how to do that. Okay. So let me walk you through, you know, the process of cubing. I would totally ignore the 4/3 pi. That's really nothing that you need to worry about. I usually just do it kind of by pieces. So I know that, you know, 2 plus h cubed is 2 plus h times 2 plus h times 2 plus h. And I know how to square binomials really easily. 2 times 2 is 4, 2h plus 2h is 4h, h to the second is h squared. So what I did is I did 2 plus h times 2 plus h squared, right? I broke it into 2 plus h times 2 plus h squared, which is 2 plus h cubed. Then I can go ahead and cube the binomial by just distributing. So I'll get a 2 times a 4, which is 8. I'll get a 2 times a 4h, which is 8h, but I'll also get, look at this, an h times a 4. So 8h plus 4h is what, 12h? And then I'll get a 2 times an h squared, so that's 2h squared, but notice I'll also get an h times a 4h, which is 4h squared. 2h squared plus 4h squared is 6h squared. And then finally I get that h times h squared over h cubed. Now, if you struggle organizationally with this, I don't want you to feel bad at all. But this is a method that's taught in Algebra 1 that I think that sometimes higher level math students kind of feel like, they're too good for, and it's kind of like, oh, that's the way babies do it. But there is nothing wrong with going back to the old box method. It's a method of distribution. So if you have, an h plus 2 and an h squared and a 4h and a 4, if any of those terms were negative, you want to put the negatives in. But you just fill the boxes in, right? You just multiply to fill the boxes in. It takes a small amount of time, longer than doing it the way we just did it, maybe, but a small amount of time. But look, there's your h cubed, there's your 6h squared, there's your 12 h, and then there's your 8. And it's a very safe way to do it. It's very effective. And some people, I think some higher level math students just feel like, oh, that's the way I did it when I was in junior high. But hey, look, if it works, it works. So you need to know what works for you, and you do it. Okay. I'm not gonna distribute the 4/3. I'm gonna leave it like that. All right. What I am gonna do is I'm gonna come in really quickly and do v of 2, which would just be 4/3 pi of 2 cubed, which we know is 4/3 pi times 8. And you know what? I'm not going to multiply that, even though it's easy. I could easily say that's 32 pi over 3. I'm not going to, and you'll see why in a second, okay? So let's go ahead and work this out now. We're going to do um, the difference quotient. So let's just call it the slope or whatever. And we'll do v of, oh, I guess we need to take the limit, don't we? Limit as h goes to 0 of v of 2 plus h minus v of 2 over h. And so I've already worked all this out, so it's a little bit easier. So I'm going to plug in the 4/3 pi parenthesis 8 plus 12h plus 6h squared plus h cubed minus the v of 2, which is just going to be 4/3 pi times 8. Sorry, I'm running out of room over here, all over h. So here's why I didn't multiply that 4/3 out, because now it's just a constant. This 4/3 pi is just a constant. So I'm just going to factor that out of the limit. 4/3 pi. Technically, I'm taking the limit as h approaches 0, but there's no h in there, right? So it's just going to be 4/3 pi, and that's cool. So here is the rest of what's going on. 8 plus 12h plus 6h squared plus h cubed minus 8. And we need that 8 and that -8 to cancel, and they do. And now we're almost done with this problem, okay? So 4/3 pi, and we'll factor the h out. We'll get 12 plus 6h plus h squared left over h, cancel the h's, 4/3 pi. I can now evaluate the limit because all I have left is the 12 plus 6h plus h squared. So let's go ahead and do that. 12 plus 6 times 0 plus 0 squared, which we know these are going to zero out. So I really am just getting 4/3 pi times 12, which is 16 pi, I think. And that's going to be in, what were the units? The units were inches. So that would be in cubic inches. So the volume is changing 16 pi cubic inches per inch of radius that's changing. And so that's what your rate would be, and that's where that's where this work back here in your workbook came from, and you can see it's pretty darn similar. Except instead of doing the work out to the side, it looks like we did the work inside of the actual problem. Here's where I must have in previous year shown people like, hey, don't do this cubed all at once. Go ahead and do it out. I mean, if you have your binomial expansion formula memorized, then you feel free to do it all at once, but most of you probably don't. So here's exactly what we came up with. Notice I factored that 4/3 out just like we did previously. Technically, technically we're taking the limit of 4/3 pi, but if it's a constant and you want to take it out, we almost never make you show that limit on the first step. The 8's cancel, and just like we got before, everything cancels, and there you go. So the volume is changing 16 pi cubic inches per inch of radius. I think maybe this is probably a better way of saying it. That was 26. Harder than 25 because you had to cube a binomial. But whether you're squaring a binomial or cubing a binomial, those are two algebraic things you have to be able to do these kinds of problems. So hopefully your algebra is up to it. So 27 and 28 are both pretty much the same problem. I'll just do 27 for you to show you kind of how that works. But it's very similar to the problem on page 22 of your course pack, and to the problem 23 that was earlier in this example. But notice first of all that our function is not going to be 1.86 t squared, because we're starting at a height of 200 and we're going down 1.86 t squared meters per second. So if you use just the 1.86 t squared, you get the right speed, but you would not get the right velocity. So I would get used to writing things out the correct way. Let's do this problem. All right. So we're going to take the limit. I'll do the work inside the problem this time instead of off to the side and then plugging it in, just to show you the variations. As h goes to 0, always h going to 0 when we're doing the tangent work with the difference quotient. So we're going to do what do you want to call this? S of t, I guess. So s of 1 plus h, because 1 second is what they want to know the speed 1 second after this rock has been dropped, minus s of 1 all over h. So that's going to be 200 minus 1.86. I'm probably not going to get this to fit. I'm going to move it. Oh, it's all stuck together. I'll just rewrite it. All right. So the limit as h goes to 0 of 200 minus 1.86 1 plus h squared. This whole thing right here is s of 1 plus h. The first part's always going to be a little bit uglier. What happened to my marker? Minus, and then s of 1, that's always just going to be a constant. That'll always be a little bit easier. So that's just going to be 200 minus 1.861 squared, right? And it's all over h. So order of operations, you got to do your squaring first. So don't worry about that 1.86. We got to square this thing first, okay? So that's going to be 1 plus 2h plus h squared after I square that out. Minus 200, so I went ahead and subtracted. And I'm going to go ahead and subtract this 2, which, by the way, I think you guys agree 1 squared is 1. And so it's just 1.86. All right. All right, so we're getting ready to get rid of some stuff, hopefully, right? So the limit, come on. All right, hold on. I'm frozen. All right, I think we got functionality again here. So what can we do? Well, we can, first of all, I mean, we might as well just get rid of these 200s. Why not, right? So the 200 and the negative 200 are gone. Now I'm going to distribute the negative 1.86. So negative 1.86 plus, actually it's going to be minus because it's negative times a positive. So minus 3.72 h, and then minus 1.86 h squared, and then plus 1.86 that was kind of hanging out over here. And what we're going to find is that this negative 1.86 and this positive 1.86 go away for us, so we appreciate that. So now all I have left is two terms that have an h in them. I think 1.86 times 272, I think I got that right. So all we have left is an h times a negative 3.72 minus 1.86 h all over h. H's cancel. I believe I can now evaluate this thing by doing negative 3.72 minus 1.86 times 0, right? And that's just going to be negative 3.72. Now, what does that mean? Well, remember, we're trying to find the exact speed using the position equation at 1 second. How fast is it falling at 1 second in meters per second? So this would be in meters per second. So this would be the velocity with the negative sign indicating that it's falling, and the speed, if you wanted the speed, like the question says, the speed is always the absolute value of the velocity. So that would be positive. And I think this is probably what's in the answer key, but I don't take points off if you leave the negative on there, because we don't talk enough about the difference between velocity and speed in this class for it to be an issue. Yeah, negative 3.72, which means it's falling at a speed of 3.72. 28 is the same problem. 28 is the same problem, just with different numbers. And probably want to use a calculator because the numbers were a little bigger with the 11.44, which is an ugly one. But I think they were trying to be accurate in a sense of being the actual gravitational constant on Jupiter. That's how fast the acceleration is on Jupiter. Much bigger planet, more mass. If Jupiter was like, I don't know, 10% more massive, it would have had enough mass to begin fusion, and we would have had a binary system in our solar system, which probably means Earth, if it was here, wouldn't be supporting life, just based on the fact that it would be between two big stars. We did 29 as an example the other day. 30 is a very similar one. We want to find where is the horizontal tangent. So we're gonna find the general form of the tangent slope and then set it equal to 0, which, if you know how to find the vertex of this function, doesn't this function factor? No, I guess it wouldn't, because you'd have negative 3 plus 1. So that would be negative 2 in the middle, so that wouldn't work. But if you did a completing the square situation, you could find the vertex on this, and then you would know, for a quadratic equation, the vertex is the only point where the tangent will be horizontal, because that's where it's changing from increasing to decreasing. But we're going to do it the calculus way now. The work, of course, is in your book, right? And here I did some completing the square to show you kind of where the vertex would be. So negative 2.7 is where the answer is. Much easier algebra to do completing the square work than it is to do this difference quotient work. But it's very powerful to be able to come up with a general formula. So let's go do it, okay? And then we're done. So we're going to do the limit as h goes to 0 and we're just going to call it f of, let's use a. I think I used x yesterday. I'll use a today since that's technically the tangent slope formula, minus f of a. And what makes this harder is that, when a is just a number like a 1 or a 2, this second part turns into a constant and the first part has some constants in it instead of just variables all over the place. Well, if we're finding a general form, we can't use any of those. We have to use variables all the way. So we're going to do 3 minus 4a plus h minus a plus h quantity squared for the first, that's f of a plus h. And we're going to subtract f of a, which is just plugging an a in instead of an x pretty much, right? So that's going to look like that. All right, so you can see already it's going to be kind of sloppy just because there's so many pieces to begin with. But then eventually we know that most of those pieces are going to cancel out. We just have to be patient enough to get that through. Drawing lines on this little thing is not as easy as it should be. So 3 minus 4a minus 4h, don't forget to distribute that minus sign, right? And then minus, and this would be a squared plus 2ah plus h squared, and I'm going to have to distribute that negative sign, minus 3 plus 4a plus a squared. Once again, don't forget to distribute the negative sign. You're subtracting the entire trinomial there, not just the first term of the trinomial. All right, so the limit as h goes to 0 of, that was better, speed. Speed cures everything. 3 minus 4a minus 4h minus a squared minus 2ah minus h squared. Remember, square the, not square, distribute the negative sign. Minus 3 plus 4a plus a squared. So how many steps was that? That was kind of algebraic tedium. Well, 1, 2, really. I mean, this step right here wasn't too bad because really we were just writing, plugging the things in. But these two steps kind of stink. Okay, I'm not gonna try to pretend that you're having fun with those two steps. But now that we get through those two steps, things are going to happen really quickly and simplify for us. So let's see what happens. Okay, there's a 3 here, but there's a negative 3 here. Those are gone. Remember, anything that doesn't have an h should go away. Like negative 4a doesn't have an h, but positive 4a is going to make it go away. Negative 4h has an h, so that's probably not going to cancel out. But negative a squared doesn't, but positive a squared is going to make it go away, right? And so pretty soon, all I have left are these 3 pieces. And so now, your problem's going to finish up in a hurry. You're going to say the limit. Maybe we should turn back to our pen, huh? The limit as h goes to 0. We'll factor out that h and get negative 4 minus 2a minus h over h. Boom, see a h, which means we can now evaluate our limit, negative 4 minus 2a minus 0. And that's your formula. This is the formula right here for a general slope at any x value, which we're calling a. For any a value that we want to know the tangent at, we know the formula. Now, that means if I wanted to know the tangent, so this, we know it's a negative x squared parabola, so it's going to have somewhat of a shape like this. So like if I wanted to know the slope over here at negative 5, the tangent slope is going to actually be positive over there, right? Because it's increasing at that point. So I could plug negative 5 in and I could get an answer. So for example, 4 minus 2 times negative 5 would be like 4 plus 10, which would be 6. So positive 6 would be the slope there. If I wanted to know, the tangent slope way over here at 10, well, it's probably going to be negative because we're decreasing at that point. And so once again, I'd plug a 10 in there, and negative 4 minus 20, right? 2 times 10 is 20 is negative 24. So I'd have a fairly steep tangent slope of negative 24. Now remember, our purpose was to find where it's horizontal. And like I've mentioned a couple times, we know that the only horizontal tangent you're going to get is going to be for a parabola at the vertex. Okay. And in general, anytime a curve changes direction, you should get a horizontal tangent because you'll have a local min or max at that point. But what we're going to do to finish this problem is just remember that the slope of a horizontal line is always 0. So 0 equals negative 4 minus 2a. Negative 4 equals, I'm sorry, positive 4 because I added it over equals negative 2a. A equals negative 2. That's the x value of your point. Now, you'd have to plug that in to find the y value, wouldn't you? So if you go back to the original equation and plug in a negative 2, I would get 3 plus 8, because negative 4 times negative 2 is 8. And then negative 2 squared would be 4, but I'm subtracting it. So 11 minus 4 is 7. So the point would be negative 2, 7. And then you're done, okay? That's what it asks for. At what point? And a point does indicate both an x and a y value, not just an x value. Sometimes people forget that. But yeah, the point would be negative 2, 7. And once again, this work was all back here for you to see. Pretty similar, pretty much exactly what I just did for you. Okay, I explained it a little bit. Notice that that point negative 2, 7 is exactly the same as we got in only about 3 steps of completing the square work. So if they just wanted an answer, that would be the faster way of doing this problem. But you're not always going to have quadratics. And if you don't have quadratics, which it's easy to find the vertices of, then you have to use more powerful methods like this. All right. Hopefully you feeling good about this. You'll have 10 more practice problems to work on today and over the weekend on page 323. Reach out if you need help. People are not doing that, and I know how many questions there should be on this stuff, and you aren't asking them. And so if you're just kind of ignoring this mathematics and hoping the end of school comes soon, you're leaving a massive gap in your comprehension of mathematics that you're going to need for calculus, and that's gonna be a terrible way to start off August. So if I was you and you're behind on what we've been doing, I would try to catch up, especially if you're taking calculus next year. You can't put yourself that far behind your classmates and feel like you're going to be in a good situation. So let me know how I can help, but have a good weekend.